Hey everybody, welcome back to iHeartStats. Today's topic is something called ANOVA. And I mentioned last time that this is sort of an extension of what we were doing with t-tests. It's called ANOVA, but that actually stands for something. It stands for Analysis of Variance, and that explains very accurately what we're going to do. We're going to look at variance and we're going to analyze it. What we're essentially doing is looking at differences between different groups, just like we did with the t-test, except in this case, it's not just two groups. It can be three groups or four groups and so on. And so that's what we're going to focus on today. If you go back to your chart for the course, you'll see we're in the same territory as we were with the t-test because we have categorical, nominal level, independent variables, and we have quantitative or interval/ratio level dependent variables. Okay, so we have that same kind of setup, but this time we can have more than two. We can have three or more in this kind of setup. Now, okay, so that's what we're going to do. The logic of this is just a little bit different than what we've been dealing with, and so I want to talk you through that so you'll understand what's happening. So this little lecture piece is all just going to be about the concept that's behind ANOVA. It's better to think that through before we start getting into all the complications of calculating things, okay? All right, so let's suppose that we have some sort of quantitative variable. And let me just use IQ as the example, okay? IQ. And so let's supposing that we had a bunch of people take IQ tests and we got their scores, okay? So here's the possible, not the possible range. I mean, you could have something higher or lower than this, but let's just say, well, you know, for most people, almost everybody really, we'd find them in this range between 50 and 100 on IQ. So we had these different people take the test and say, you know, so somebody was right around here, another person's score was here, here. We'd expect more clustered toward the middle here. Okay, so that's the setup. And then we went ahead and we calculated the mean score. So let's say the mean turned out to be right in here, okay? That's the mean, our X bar, okay? Now, each one of these scores differs from the mean. So that's the variance, that's the variability that we're interested in. So this score right here is just a little bit away from the mean. These ones are further. These ones are way further, so this distance away from the mean is the variability that we're interested in. If there were no variability, everybody would have the same score, it'd be the same as the mean. But with these, we actually have some variability. We have a little there introduced by that person, we have a little more there, and we have a lot introduced by that person. We have this variability, okay? And that's what we want to analyze. And then, once we do that, we want to try to figure out what's responsible for that variance. Why is this person so high and this person so low? Why is this person so close and this person not? And so on. We want to see what's behind that. And we might guess some different things that might be producing the differences in IQ. Okay? So that would be what we're trying to do with ANOVA. With ANOVA, though, it's got to be the thing that's explaining the difference has to be something that's categorical. Now, I'm going to talk about linear model, as we call it, in a bit more general terms before I really turn to ANOVA specifically, just to help you understand this idea of variance and what we're trying to do with it, okay? So what I want you to do is just think about three things that might be related to IQ. What might be related to IQ? Let's think of something that we think actually would not be related, something that we think might be somewhat related to IQ, and then something that we think would be very highly related to IQ. All right, so those three things are, just for the sake of our example, let's say unrelated would be shoe size, okay? So we might not expect shoe size to actually have any relationship with IQ. That would just kind of be random. Something that would be somewhat connected to it would be income, let's say, okay? So, you know, we think that people who are smarter in general might make more income than people who aren't as smart, okay? And then last, something that we think would be really highly related to IQ would be your grade point average. So how did you do in school? You would think that would have a really tight relationship with IQ. All right, so let's just take those three and think about them on little charts, and that'll help us think about how this kind of analysis of variance kind of thing might work, okay? So let's take the shoe size one, okay? So supposing this is people's shoe size down here, and this is their IQ up here, okay? So I ask each person, what's your IQ, or give them an IQ test, and then I find out what their shoe size is, and I plot it. So I have, this person has a small shoe size and a low IQ, and then this person has a small shoe size and a large IQ, and so on. And so I have all these data points of these people. And it just looks like a random scatter of points because there's not any relationship. Shoe size doesn't really predict IQ. And so this would be, say this is the mean of IQ there in the sample, and we have these shoe sizes that are just randomly scattered all over the place. So what's happening there is that shoe size is varying, but it's not varying in a way that's related to IQ at all. Okay, so IQ doesn't explain that variance. Once I put that IQ in there, it doesn't help me get rid of any of the variance. It's still all there. All right, so there's one where it's not related. The variability in shoe size is not related to the variability in IQ. All right, let's go to a different one. Let's say income. Now I'm just going to flip it here because we're more likely to think that IQ is going to predict income than income is going to predict IQ. Okay, so let's just, for the sake of keeping this conceptually clear, we'll put IQ down here. So low IQ, high IQ. All right. And then over here we'll have income. All right, so we expect there to be some kind of relationship here between these. So it might look something like this, okay? So we'd have the data. So, I got the person's IQ and their income, and I'm just plotting them out. Okay? So maybe it looks something like that. Okay, so now we can see there is kind of a relationship in here. All right? So as people's IQ goes up, their income tends to go uphill, but this doesn't take care of all of the variation. There's still a lot of variation left. There's a difference between this score and the line. I mean, this person's way off the line. So there's a lot of variability that's left over after I stick the line in the data. Compare that to something like the GPA example where we think it's going to account for a lot of the variability, okay? So let's just draw the same thing here. Except this time we have IQ down here, and we have GPA up here. And this time, since they're very closely related, the data is going to look more like this. So as IQ goes up, GPA goes up. All right, it's the same kind of relationship we had here. But this time, IQ accounts for a lot more of the variability. There's hardly anything left in the variability of GPA once I draw this line in here. These things are very close to the line. So instead of having these big parts that are deviations from this line, I only have little tiny deviations from this line. The variability in GPA or variability in IQ that accounts for the GPA. So there's very little left in that GPA after I account for IQ. That's what we're doing with when we're analyzing the variance. Okay, now in these examples I had continuous independent variables, and in ANOVA we don't have ones, we have groups instead. So we're going to come back to things like this when we get to regression and correlation, where we have interval or ratio level variables on both parts. But this same general model applies, and ANOVA is part of this class of things that we're going to do in the next chunk of the course called the general linear model. And so this concept kind of applies to ANOVA and regression and correlation, our next two topics.